All right, welcome back everybody. We are moving now into project 5 of our Arduino project book. And in this one, it's the mood cue. And we are going to use a potentiometer to rotate a servo motor. Potentiometer just being a little device we kind of hold in between our index finger and our thumb, and we rotate it left to right. And I guess in this one, the more we rotate it, the better or worse our mood is. Okay. But before we jump into the code on this first video of Project 5, I want to take a look and make certain that we understand exactly what a servo motor is. And if we look at this slide here, this is a bunch of formality. It's it's a pretty formalized definition. But essentially, when we talk about servo motors, it's a mechanism that allows us to rotate between 0 and 180 degrees. Now, the one thing about a servo motor as well is when we give it an angle to rotate to, it goes to that angle and it remains at that angle until we give it another angle to rotate back to or further on. If we take a look at that graphically to make a little bit more sense out of it, if we give it a value, in this case, -45, the servo motor rotates and it stays there. And it's going to stay there until we give it another value, in this case +45, and then it'll rotate to that angle and stay there. And so the angles that we're going to get from our code base come in from the potentiometer as we kind of twist it, and it goes gives that angle to the servo motor, and it rotates. So now that we kind of have a better picture and understanding what a servo motor is, let's go ahead and hop into our code. Here we have our standard setup and loop, nothing new here, right? Now the one thing in this project is we have this include of a servo header, and you can see that we instantiate a variable that we just named myServo of type servo, which is a library that the community has put together that makes it very easy to control servo motors from an Arduino board. Essentially, all we have to do is connect up a write pin and start writing angles to it. Now, that's pretty much about the extent of it. It's pretty straightforward. And we'll see that here in a moment. But that's why we're including this library, header and library, to actually use our servo, the interface to our servo that makes things much easier. But the first thing that we need to do is we need to read in from our potentiometer. And our potentiometer is going to be an analog input. And here we are going to be reading in on pin A0, our analog input. And the next thing that we're going to want to do is write out to our servo. And on that one, we're going to do it on a digital pin, in this case, a pulse width modulated pin, pin 9. And that's the value that we're going to use to write out an angle to the servo motor. And here, the next two variables that we have is the angle that we're going to ultimately write out. This angle is going to be calculated based off the potentiometer's input. From there, we're going to calculate up an angle to give back out or write out to our servo motor. And so that's what these two variables here are set or put into the code to capture. In our setup, we're going to do the kind of standard typical serial configuration with a baud of 9600, and this is just so we can see our print statements on our computer. And then you'll notice that we go into our servo motor and we attach pin 9 to our servo, meaning that our servo motor is now listening on pin 9 for the angle that we're going to write out to it. That's pretty much all we need to do for setup. Pretty straightforward. Here we have this analog read, right? And we're going to be reading in from our potentiometer. We're going to grab that potentiometer's value and we're going to map that value that we read from the input on the analog so that we can write it out to a digital output. If you remember, our analog inputs can be 0 to 1023, right? Because they have 1024 potential options, right? Values. 0 is one of them, so we get 0 to 1023. Now our digital outputs are typically 0 to 255. However, here you'll see the 0 to 179, And that's because, like we said, the servo motor only rotates from 0 to 180 and -1, right? So 0 to 179. We'll talk more about this mapping in a moment, but that's essentially where those numbers are coming from. The next thing that we're going to do, once we get that angle that we've mapped from our potentiometer's analog input, we get the angle and we're going to write that angle out to our servo motor, and that's pretty much about it. The reason we're going to do a delay is to make certain that the servo motor has a little bit of time to actually rotate. And before, if you're rotating the potentiometer very quickly, the delay kind of gives the actual CPU time to process it, send that command off to the motor, and let the motor actually do the rotation. The only other code really in the book is just some print statements. Again, once you have everything working, you really don't need to worry about these print statements very much, but they might be helpful as you're developing. But anyways, that's pretty much it for the code. There's really not a lot to it. You got a servo, you attach it to a pin to listen to, and then you start writing out angles. The one thing I want to go over really quick though is the map function, to make certain that we all have a very good understanding exactly what this function is providing for us. And like I said, we're looking at the potentiometer's value, and that we know that we're reading that in from an an analog input, and that analog input can produce a value between 0 and 1023. And we're going to write out to a digital pin, which can take a value between 0 and 255. But we know that on this particular pin, there's a servo motor on the other end reading from it. So the servo has to take a value between 0 and 179. So essentially what we're looking at here is a function that allows us to take an analog value and convert it to a equivalent value that has a smaller range. In this case, our first range is from 0 to 1023. Our second range is from 0 to 179. So what does that mean? Let's pretend that we get a value of 512 from the potentiometer. Give or take, that's roughly 50% between 0 and 1023. So the equivalent of 50% on 0 to 179 is roughly 90 degrees, right? That would be your angle. Or let's say that we got a value of 256 from the potentiometer. That's essentially 25% of the value between 0 to 1023. And in that case, it would map that 256 to a value of 45, which is approximately 25% of the way between 0 and 179. So it's just the mapping, right? You get an analog value, you map it to something that is within the range that you provide. In our case, we want it within the range of 0 to 179, so our servo motor can rotate accordingly. And that's really all that the map function is actually doing. And so anyways, that I know that can throw people for a little bit of a loop, so I wanted to make certain that we had that one kind of in the bag behind us for clarity before we move on to looking at the board. But essentially, that's all that there is to the code for Project 5. And in the next video, we'll go ahead and start the board walkthrough. So we'll see everybody there.